This video is a continuation of the inverse trig function graphs and how it relates to the principal values and finding the inverse functions. So just as before, here's one cycle of tangent. Now I put the asymptotes on here because we're not going to include those values, but we're going to get close to them. That doesn't break the fact that this is still a function, but if we were going to do another cycle, here's our other cycle. And now no longer a function because you're hitting at 2 points right there. So same reason. Again, we're picking the part that's closest to the origin. So, and that's more positive. So like the cotangent one's going to be the more positive of that spot, same as cosine. So tangent going right through the origin, that cycle. Now, our domain for this is negative infinity to infinity, so we can do tangent inverse of any value because that was our original range. And technically also there are arrows on the ends here for the graph and the asymptotes to show that it does keep going. The range, however, is going to be negative 90 to 90 or negative pi over 2 to pi over 2. So notice not actually putting brackets there. That's something to star. So although sine and tangents values are similar, because there are asymptotes and tangents undefined in those spots, we don't put brackets. Now you still could give an answer for that. You could say that the answer is undefined. So if you had to do inverse tangent of 90, your answer would be undefined. But we're not actually giving a value answer for that. And then the same thing as before, the principal values are also going to be the same values as the range. And these values are the values you are going to use to determine where the inverse of a value is going to fall. These are also values that if you plugged in the calculator would give you that principal value answer only. So for tangent similar to sine. Tangent, I think, and sine are pretty easy. Reference angle for root 3 over 2 is 60 degrees. So your answer is just going to be negative 60. So you can get that in the fourth quadrant, but it still be between the negative 90 to 90. I threw in an inverse tangent of 1 just so we remember that value is our 45 degrees. Should probably put radians in with this also, or pi over 4. And then this is 60, negative 60, or negative pi over 3. Now, if it doesn't specify radians or degrees, you can really do either for this type of question. And then again, inverse tangent of root 3 over 3, your reference angle for that would be 30 degrees. But again, it's negative, so it will be negative 30 or negative pi over 6. Now, you will have to be careful with cotangent because although when we do the inverse secant and cosecant, we're going to use the reciprocal functions, kind of like we just did with graphing, we're not going to do that with cotangent. So if you remember for graphing, we kind of graphed cotangent and tangent as their own separate graphs, and we didn't refer back to the other one just in the beginning to kind of figure out where the points were, but that was it. Same thing for inverse cotangent function. It's got a different graph. Same domain, but different range, so different principal values. And the principal values for this one are actually going to be the same as cosine. So cotangent starts with a C, cosine starts with a C, same principal values. That's the only thing they, well, not the only thing they have in common. Remember, they did have asymptotes in common. So that's something that kind of stands out from the graphing already. Now, same idea. 0 to 180 or 0 to pi. And that's actually the range of your one cycle from before also. No brackets because there are asymptotes on those points. And same thing here. I forgot for the domain, there should be arrows. Technically, there should also be an asymptote line here if you want to sketch that in, but you recognize that that's the case. Principal values will always match up with your range values. So again, if we did do inverse cotangent of 0, you would get undefined. That's why there's a parentheses there. There's not an actual number answer for that. Now, you're probably going to want to know the values for cotangent or just get the idea of the reference angle from tangent. So the reference angle for this inverse tangent of root 3 is 60. So for cotangent, it's going to be the 30-degree one. And then inverse tangent of root 3 over 3 is 60. So your reference angle for that is going to be 60 for cotangent. Now, if it's negative, rather than doing negative 30, we're going to do 180 minus 30 to get 150, or 5 pi over 6. Should put the word or there. Because we want to get it in the range, or in that principal value range of 0 to 180. So a negative is going to end up being in the second quadrant, and positive. Positive angle is easy. Whatever your reference angle is, that's going to be your principal value answer. So you're all set. So I would star cotangent and cosine. When we get into doing the problems, those are going to be the trickier ones to work with because you're getting an answer in that second quadrant if it's negative, whereas sine and tangent are easy. Your reference angle, you just put a negative sign with it, and that's going to be your negative answer. But we will get into that in the next lesson where we're actually doing the inverses and some composition of functions. So again, this is just your intro to show you why we're picking certain values. We're looking to see where the inverse is a function. So that's, again, the main gist of what a principal value is. Definition's on the front. And that is something you want to go back and study for quiz time, that definition, and test time too.